and welcome to the stream. My name is Rachel Tatman. This is my YouTube channel, and it's for anybody who cares about language technology and other people, and also checking their audio levels. We're good. All right. So I actually had something else planned for this week, but I bumped it back to next week because last Thursday we got a fabulous question in the coffee chat from Frank Hahn. So thank you for the inspiration, Frank. And he asked, I was wondering why sub-word tokenizers like word piece are used, but not something like syllables, which is such a great question. Right? So I think most people know that words can be further broken down into smaller units. So that might be, individual speech sounds. It might be features of those speech sounds. I don't know, that like voicing and like manner are general knowledge, but maybe if you watch my channel, you would consider it to be so. So that's what we're going to talk about today. Why don't we use syllables? And today, because I think this is best illustrated using code. I don't have slides. I have a notebook. And let me actually just pop a link to this into the chat so you can check it out if you like. And I'll add it. I'll probably do a comment down below afterwards if you are interested in checking it out. So the like trivial answer is no one uses syllables because no one uses syllables, so there's no quick and easy tool to do syllable tokenization, so people don't do it, right? It's community effects, founder effects, etc. But I think that begs the question, okay, well, why doesn't anyone do it? And I think it's a great question, in particular because we have very strong, behavioral evidence that syllables are a concrete unit of language in a way that things like perhaps even individual speech sounds may not be. So even in non-literate populations, like very young children, there are a lot of language games that rely on being able to break language down into syllable structures and then manipulate that. So Pig Latin is an example, which is a language game. Oh, I didn't finish this. I was gonna write, come on, ubby dubby in here, which is something that I can't play. Like I've never learned ubby dubby, I just sort of know about it. But these are games like for Pig Latin, you would take the onset of the syllable, move it to the back of the syllable. Nope, the word. It's usually the word boundary. It's a language game, right? There aren't like good rules for it, but they do involve like breaking things into syllables. So we've got good, behavioral evidence that this is a way that people think about and break down language. I think ubby dubby more specifically uses Syllabification, but like I said, I don't know the rules to ubby dubby because I never learned it. So syllables probably exist in some sort of perceptual space. We have a lot of like also poetic evidence where even in oral traditions, again, they're non-literate, they're not coming from a writing system, which is like an additional layer of structure that's been imposed onto the way that people think about, think about language. You still have these sort of reflexes of syllables. Anyway, they maybe exist. Perceptually, they're probably something people pay attention to. So why don't we use them as tokenizers? Let's talk about tokenization first. So I am talking about tokenization here for English and languages that tend to use the same types of tools as English. So if you are using a language with a syllabary and you're taking written text data, so like Korean like letters represent a syllable, Cherokee letters represent a syllable. So in those languages, any character level model is trivially a syllable level model because that's encoded in the writing system. I don't want to get into an argument about what constitute words in Chinese, but arguably Chinese characters are also syllables. So I'm not going to get too far into that. I'm not a sinologist. It's not my area of expertise, and I know there's a lot of disagreement in the area. So we're just going to be working with basically languages that are written using an alphabet. And I'm going to go even further and say an alphabet where both vowels and consonants are represented as sort of equivalent types of characters. So things like not the Arabic writing system where vowels would be pulled out because you could then use the vowels to determine the syllable structure. So I'm narrowing my focus a lot here is basically what I'm saying. So tokenization we do to break down text or written or signed language into smaller units that we can then do things with. So commonly, these days people are generally going to do tokenization, use those tokens to either load in pre-trained embeddings or to train their own embeddings. The embedding process turns the text into numbers, and then from that you have your feature input for the rest of your model, whatever you're doing. In a sort of non-deep learning world, so before, let's say, embeddings were a thing, tokenization was done for counting things and parsing and similar things, right? You're just breaking up your language data. And part of the reason of why you do that is if I am breaking language data into chunks, I am more likely to see repetitions of those chunks. So I'm likely to see more examples of each type of chunk, which means I can learn more information from it. If I am, I'm not a human, right? Like I am a computer, and for me, a unstructured text is just that, unstructured. And if the chunk level is, let's say, the whole text, right? Every time you're training your model, each input is an entire novel worth of text, let's say. You're not going to get a lot of repetition there, right? Because most novels don't repeat each other word for word. Instead, you're probably going to want to break down that language into some sort of smaller unit that you can then see multiple examples of or be able to generalize from. The general idea. So the smallest unit, again, for English type languages is going to be characters. Character embeddings are used. They tend to be used particularly when you have super large models. So if you have a lot of data and a lot of parameters, and you can pick up on those sort of like fine-grained distinctions. So I believe DALL-E uses character level tokenization, or potentially byte pair. Byte pair I'm not going to talk about too much, but it's usually starts with character level tokenization, and then you learn other tokens that are more frequent to sort of increase your vocabulary size, yes, but sort of the minimum amount you need to do for, whatever goal it is that you have for, model size or sparsity or whatever. So I'm going to ignore byte pairs. I know that they exist. Morphemes. So morphemes are units of meaning in language, and it's the smallest unit that has meaning. So English doesn't have a lot of multi-morphemic words looking across, all the various types of languages and types of ways that they do things. But we do have some. So for example, if we're looking at the word characters, we can break that into character, which is one morpheme, and then s, which is another morpheme. And this morpheme means, hey, whatever I'm on the end of, it's plural. There's more than one, right? Or like words, we can break down into word and s, again, which means multiple, right? There's the pluralization morpheme in English. So in a morpheme level tokenization, this would be 2 tokens. In a word level tokenization, this would only be 1 token. In English, people tend to use words because it is faster and easier. So English, like I said, tends to have pretty simple words. They don't tend to have a lot of morphemes in them. And we have a consistent separator character between words. So it's either going to be a punctuation symbol or it's going to be a space. That is a small set of characters. It's pretty easy to just like scan through a text string, be like, is it a space? Is it punctuation? Is it space? Is it punctuation? Yes, there's a break. Yes, there's a break, right? So it's very, efficient to do that. It's very easy. Morphemes, you have to have a little bit more complexity in breaking them apart. So word piece is a kind of, it's kind of a morpheme tokenizer. I believe I used morpheme piece in my examples further down. And the challenge here is that there's not always let me give you an example. So give you the example grocery, right? Like when you go and buy food from a grocery store, I guess. And the pluralization of that is groceries. So you have this sort of stem that's the same in both of them, but this is one morpheme, right? This Y here doesn't mean anything. It may historically have at one point, but I would say that currently to an English speaker, it doesn't mean anything. And then here, the plural morpheme is this ES, and then the stem has changed this Y to an I, right? Whereas in something like horse to horses, this same morpheme, right, is just an S, and the ES, and the fact that it looks like this ES is just a coincidence, right? The root of horse is not horse with no E on the end. It has the E on the end. Oh, hey, Luke. Hi, bye. Maybe I'll get you on the replay. Overlord Zenu says, I'm learning. Oh, good. I'm glad. Learning is cool. Anyway, so that is to say, I can't just have a morpheme tokenizer that's like, hey, if there's an S at the end, it's always plural. So some other examples, right? Glass, grass, miss, right? These are all words that have an S on the end, where it is not plural. Or in like a loan, like les mis, this kind of is plural, right? It's from the French, but this one definitely isn't. You might be able to argue that this one is, but if a tokenizer gave me this out from les mis in, I would be upset. I'd probably want it to be les mis, L-E-S-M-I-S. So basically, if you're going to use morphemes, you have to use a bunch of hand-built rules built by linguists, or you have to accept a certain amount of wrongness in your tokens. So it is pretty complicated to get morpheme tokens. Why would you want them? For languages like German is like the classic example. The joke is always like, oh, German words are so long. Well, yes, but they're long because there's a lot of morphological complexity, and you can take a lot of little morphemes together and squish them into a really long word. So if you've heard the like thing about like, oh, you know, in Inuit there's 100,000 words for snow or whatever it is. Kind of. I mean, they have a lot of morphemes and they can stick them together into single words. So in English, we might say something like, oh, it's a really like wet, heavy snow. In a language with a lot more ability to stick morphemes together, that might be a single word, but it's formed from the bits pretty much every time. And the way that you form it, you have a lot of flexibility, right? It's like Legos, basically. Hey, Alpha, welcome. Sorry, Afla, my apologies. I read that wrong. So, in a language where words tend to be very long and don't have a lot of repetition, right? Because if you're using this rich morphology and like constantly creating new words, you're not going to see many examples of every word because each word is more and more specific to the use case, basically, if that makes sense. Then it makes sense to use a morpheme-based tokenizer because you will see more individual instances of each thing. You'll see more examples, you'll see more context. It's easier to learn. It's sort of the basic general idea there. Afla says, with all these heavy deep learning techniques, do people still use handwritten rules for pre-processing, things like stemmers, or do people just throw compute at it? Yeah, absolutely. I mean, I can't speak for, the deep minds of the world. I don't work there. But for people who are building things that need to work, yes, handwritten rules are extremely common. So I think a great example of where handwritten rules, it's not really a stemmer, but so Duckling, which is a library for extracting times and dates from raw text. It's all completely handwritten rules. Yeah, it's just faster and easier, and trying to do a deep learning approach to that would be very time intensive and much more often. So yes, absolutely, people still use rules. And again, like just throwing more compute at it is probably going to work if you have a lot of data. But, if you're working with a language like, Tamil, right? Very widely spoken language, a lot of speakers, not as much language data for it as you might expect given the size of the speaker population, just because it hasn't been, you know, a priority for the people who have the money, basically. In that case, if you have sort of scarcity of data, the scarcer your data is, the more helpful rules are going to be because they can help balance that and offset that. Yeah. Andre says, I learned English in the BBC and VOA translations and podcasts. Ooh. Yeah, I think the American government runs VOA. I think that's Voice of America. I've heard about it, but I don't know that I've ever listened to it. So those are sort of the things that people do for tokenization. They do character tokenization, especially if you have a lot of data. They have byte pair tokenization, especially if you care about computational efficiency and memory. They use morpheme tokenization, particularly for languages that aren't English. You can do it with English, but people rarely do. And then word level tokenization, which works well if you're using a language, if you're looking at a language where the words tend to be pretty short and simple, like English. So why not syllables? So syllables would sort of go in between morphemes and characters, right? So they'd be, you know, smaller than morphemes sometimes, but longer than characters sometimes. Usually most syllables are more than a character long. Why wouldn't you do them? So there's a couple of reasons, and I've just spilled tea all over myself. It's cold, don't worry. So like morphemes, it requires hand coding rules. So it's not, it is not trivial to look at a, right, like Staffordshire and build a rule that will, just looking at the characters, correctly identify the syllables. So basically what you need to have is you need to have access to a pronouncing dictionary, is usually how people will do this, like, what's the DARPA one? Anyway, there's a bunch of pronouncing dictionaries that were built when, for English, particularly American English, when speech recognition technology was sort of getting off the ground in like the 70s and 80s, that are still around and people still use. So you'd have to have a word in a pronouncing dictionary. The pronouncing dictionary would have the handwritten syllabification, probably done by a linguist. And that's how you determine where the syllable boundaries are. And then you'd have to have another mapping from that pronouncing dictionary to the way that the word is written, which is in English, as you know, y'all have learned English, as you know, is not a straightforward mapping as it is in other languages, right? So like Hangul, the Korean writing system, very straightforward. You always know what a character is going to sound like. It's a syllable, it's always the same. Whereas in English, you know, this is not Staffordshire, right? It's Staffordshire. So this does not sound like ord here, it sounds like erd. And there's no way of knowing that unless you have learned this word previously. So it's got to be a bunch of hand-built rules. And I have some examples here of why you can't just do it with regular expressions based on the characters. So here you had Staffordshire or Staffordshire. So you might syllabify this as Staffordshire or Staffordshire, Staffordshire. And again, the letters don't have like a strong relationship to the actual pronunciation, so you know, you kind of have to guess. It's very much a guessing game. So I think somebody on Twitter mentioned that they would have tokenized in the video title, like thumbnail, I had like tokenization, or tokenize, where I was by itself and the N was part of token. And honestly, mostly I did that for readability because there's a morpheme boundary there and it's easier to read if there is a, if you don't have like something in the middle of the morpheme boundary. But yeah, it's, you know, there are multiple ways that you could syllabify things, and your particular beliefs about how morpheme boundaries and phonological representations interact with each other as a linguist is going to determine where you put them boundaries. So you have this, string here, right? Shire, which could be shire or sure. So one or two syllables, both are correct. However, in this string, shire, it has to be two syllables, right? It can't be sure. If you syllabified this as sure, it would be a different word. So even though, you have some examples for this exact text string, those examples are not going to be unilaterally correct across the board. Another example here, you have shifts, which is one syllable. This is one of the longer syllables in English. However, if you have this exact same string in shift stick, it's like if you know how to drive, there's automatic where the shifting of the engine is done for you, and then there's manual where you do it, and the tool that you use, or in this hand, whichever one that's in the middle of the car that you use to actually change the gear is called the shift stick. The shift stick, the syllabification goes in the morpheme boundaries, so shift, stick. And again, shifts is a completely allowable syllable in English, but it's not shifts tick, it's shift stick, right? And also there's stress, and I'm not talking about stress, and I know that I'm not talking about stress, and we can talk about that later if you care about it. Andre says, Google Translates makes the audio like real human speech. Oh yeah, that's the... I read that paper. It's been a while. Not the waveform one. Oh, it'll come to me. Yeah, I'm familiar with the system. It's pretty cool. So basically you have to do the exact same thing that you do with morphemes, where you have to have a bunch of hand-built rules, which, wow, it's expensive to do, right? And you can imagine, let's say I'm working with Swahili, and I'm like, oh, I need syllabification for Swahili. I'm gonna need, a bunch of Swahili linguists to sit down and tell me what a syllabification of all the words in my vocabulary is. And that's, that's non-trivial. So as a result, you have a pretty difficult thing to do, and you don't get great payoff from it. Right? So with characters, the reason why you would use character embeddings or character tokenization is that there aren't, especially in languages like English, a lot of characters, right? So there's, 26 if you're looking at just alphanumeric characters lowercase, 52 if you're looking at uppercase, and then like a scattering of punctuation. It's a very small set. And, probably even in this notebook, I probably have an example of every single one of the characters. That is not true of morphemes, right? I don't have an example of every single morpheme in English in this notebook, and I certainly don't have an example of every single word in this notebook. So the density of occurrence of characters is quite high. And you also have a low vocabulary size, so it's, less, right? Like if you're thinking about it like a Python dictionary, there's just like less entries in the dictionary. Although dictionary is not maybe the best example because lookup time is going to be static. So every token, the flip side of that is that every token is not very informative, right? So if I just say, what does H mean? It means nothing, right? In English, that's not a morpheme. There's no meaning associated with that. It has meaning in context, but I need a lot of context to learn that meaning if I'm a model, right? And basically the less informative each token, the more data I need in general. So it's, if you've got a lot of data, character tokenization may be a good choice. You're going to need a lot of data, but it's very easy to do character tokenization as well, right? You're basically like, if you're using, UTF-8, you're like 8 bits, next one, 8 bits, next one, right? Pretty straightforward. It's also unsupervised. You don't need data, you don't need training. You can just do it, and that should be an E. And it also extends well to out-of-vocabulary tokens, right? I don't need to know what a token means to tokenize it correctly using character tokenization because it's just every character gets broken apart. So it's very flexible, it requires a lot of data, it's very fast, it's very efficient, and it doesn't take a lot of storage space. Morphemes, on the other hand, they're a bit more sparse, right? So like I said, I definitely probably have every character in English in this notebook. I definitely don't have every morpheme in English, but I probably have a fair number of examples of at least the most common morphemes, right? And every morpheme is informative, right? So if I said, let's looking at sparsity, right? You could tokenize that into sparse and itty. And I was like, okay, does sparse have a meaning? Yeah, it does. It means, scattered, few. And itty, right, is a grammatical morpheme that takes a adjective and turns it into a noun. So I know that this is a noun, right? So both of the morphemes in here are informative, which is good. So it's harder to break words into morphemes. Again, I need rules. I need to have had a linguist at some point sit down and do some stuff. But if I am especially working in a language like German, where it's going to be much rarer to see repetitions of words, I'm more likely to see repetitions of morphemes, so it's going to probably be worth it. Andre says, what about pronunciations from other languages, such as the Greek for archive? Oh, yeah, the is there an I in it? I think there's an I in it. For those of you who don't know, yeah, that's right. It looks right. So the website where people upload preprints, which is are like the English words, and then this is meant to be read like the Greek letter chi, chive. I feel like there's an I in it. Anyway, I'm dyslexic. I'm not the person you go to for spelling. Yeah, so I think that's a question about out of vocabulary tokens, right? So if you, or potentially about, pronunciation dictionaries. If you were working with like a text-to-speech system, I would just add this, right? As a rule. Generally, you can do that for most sorts of systems. And just say that this is pronounced archive, which if you are using Alphabet, let's let me try and dust off my Alphabet. Alphabet is a ASCII-based phonetic notation system for English developed by the Advanced Research PA Projects Association, I think. It's a American Department of Defense thing from, again, the 60s, 70s. And a lot of pronouncing dictionaries are written using Alphabet. So it would be yeah, I think that might be the Alphabet. Let me know in the comments if I'm wrong, but you'd transcribe it like that. So you'd add this as a rule, being like, that's how you say it. Yeah. But that's more for, that's more of a question about a particular part of a text-to-speech system than it is about tokenization, because at that point, the tokenization's already been done. So morpheme tokenization, I mean, probably not worth it in English, but definitely worth it in languages where you're going to have less repetition of words. Words can be very sparse, right? So the longer your, the string that you're looking at, the less it's going to be repeated. The more examples you're going to need to see, basically. But they're very informative, right? So even more so than morphemes, because there's more information in a word than a morpheme if the word has multiple morphemes. And in English, it's extremely simple, right? So you get the benefit of having meaningful units without the drawback of having to have a bunch of hand-built rules to do it. So if you are working with a language with pretty short words where there is a lot of white space between tokens, this can be a very, again, computationally effective, efficient way of doing tokenization. With that said, syllables kind of don't get you this. So syllables, semantically uninformative, they don't mean anything. And if you do get something that means something, probably it's actually a morpheme on accident. Or it may, in fact, be not a morpheme and just look like a morpheme because the syllabification is not necessarily going to respect morpheme boundaries, right? They're also sparser in characters, right? So I probably don't have every syllable in English represented in this document, even though I definitely have every character in English. And they also require a supervised hand-built tool to get them, right? Someone has to tell you what the syllabification of every word is. Again, if you are not working with a language like Korean or even Japanese, I think Japanese writing systems are pretty complex, but I'm pretty sure one of them is syllable-based. People do use them. I will say that. People do use syllabification information. So for measures like readability, generally a measure of how many syllables there are per word is included. Also for breaking lines, doing line breaks. So LaTeX has built-in syllabification for English and some other languages to know, if I have like a string of text and I'm trying to like justify it so the margins are in line with each other, you want to do that break at a syllable boundary. So there are reasons to do syllabification, but not necessarily for tokenization. And just like as a general example, we are going to talk about some code examples, so don't worry. The shorter the token length, the higher the frequency for every token, or n-grams, right? So like a 2-character long string is going to be more common than a 3-character long string, regardless of what the string is, because THE, very common in English, TH, even more common because it's going to occur every time you see THE, and also in places where you don't have that E on the end. Less sparse, you're going to see more examples of it in more places, and the smaller the vocabulary size, which may or may not be a constraint for compute memory. Yoshiva says, how do you do multi/cross-lingual processing like Similarity? Also love your videos. Oh, thank you. So is this an example where you are looking at, I don't want to get too sidetracked. I might come back to this at the end. But I would say that it's a different question if you are looking at, 2 documents and each document's in a separate language, or if you're looking at something where there is one document that's in multiple languages and another document that's in the same set of languages, have different things. And one approach that's been particularly sort of popular, I guess, lately is multilingual embedding space. So basically you embed everything in the same space. So star, is that the Facebook algorithm for... the Facebook one is also for multimodal embeddings as well. It doesn't just have to be text. But basically you put everything in the same embedding space and treat them as, they go in the same vectors and you rummage around in there and do what it is you're trying to do. Alexi says, sometimes I think it's better for the humans to learn a new language, better understood by machines, than to try to teach machines to understand our language. Ooh, I would strongly disagree with you there. I would say that if you speak a language that is not well supported by natural language processing, the issue is with the technology and not the language, right? Human languages are things that we have developed organically to, meet our needs, our like fundamental human need for communication. Every language is equally good at meeting that fundamental human need of communication. The fact that a technological tool cannot interface with it is a fault of the tool and not a fault of the language or the language users. Yeah. And I mean, obviously I personally benefit from, English being the thing that everyone works on, but I wish they didn't, right? I wish we worked more on different languages that are, important to us and our communities and meet fundamental human needs. Alexi says maybe Muse. I don't know what you mean by that. Anyway. So I've just said a bunch of things with 0 evidence. Well, no, that's not true. I had a lot of linguistic evidence, but I'm going to show you a little bit more clear evidence. So first of all, I'm going to install a package, a morpheme piece. So this is you may be familiar with word piece, sentence piece, morpheme piece. These are a collection, I would say, of tools for cutting text into chunks that do it at the level of what the thing is before the piece, right? So word piece breaks things into word pieces, kind of, more or less, breaks words into pieces. Morpheme piece breaks things into morphemes, again, more or less. I don't know why I said morphemes and not morphemes, it's morpheme. Word sentence piece breaks things into sentences, etc. And then I am using R for this, and the reason I'm doing that is because I'm doing some graphing, and I don't like graphing in Python. I find it a huge pain in the butt, especially when the R libraries are just so simple and straightforward. But I mean, everything that I'm saying here is going to hold regardless of what tool you're using for tokenization. Oh, Muse, the cross-language thing they had in Facebook. Yeah, that might have been their multilingual embedding thing. Let me... Is it Starspace? Yeah, it is star space. So star space is a general purpose neural model for efficient learning of entity embeddings for solving a wide variety of problems, learning word, sentence, or document level embeddings, information retrieval, blah, 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 blah. So yeah. All right, and then the text that I'm going to be using here as an example is the UN Universal Declaration of Human Rights, which I like using as an example because it's, I don't know, I think a lot of people have read it, and human rights are important, and it's good to talk about them. Also, it's like a good length for sample text, and it's not just like another Jane Austen novel. No hate to people who use Jane Austen novels as their examples. Nothing wrong with Jane Austen novels. They're a little bit long for just showing examples of stuff. All right, so let's do some tokenization. That should be fine. Okay, so first of all, we have the character level tokens. Super straightforward. It's just split every token. I'm pretty sure the Python built-ins are pretty similar. And then splitting the word tokens, split on spaces, again, pretty straightforward. And then I'm also doing the morpheme piece tokenization. So this is a little bit more involved because you need to have a place to, what's in your vocabulary and, where are you looking to look it up. You also see this UNC token. So UNC, UNK stands for unknown. So if we run across a token in our text that isn't in our morpheme breaker aparter and it doesn't know what to do with it, it will just replace it with this UNK. And this is the max number of characters. I'm actually gonna, I don't know how many characters are, but I'm gonna try and make sure I get them all. So I'm just gonna say 10 million. So let's run all of those. And the one that here is taking a bit is the morpheme tokenization because it's looking it up. And then, so those are all pretty straightforward. People do these fairly commonly. There were built-in tools I could use. The syllable tokenization, a little bit weirder, a little bit harder. When I was looking online for different things that people did, a lot of things that people had done previously involved looking things up on a syllabification dictionary, which is now defunct and no longer online. So I used this project called Corpus, which is used for corpus linguistics measures. And one of those, like I mentioned, is readability. So it has basically it looks up the syllabification of words, and then it's used for, determining readability, but instead I just sort of messed with the, actually do this while I'm talking, but instead I just messed with the output and rejiggered it so it had basically the same format as the rest of my stuff. So we can take a look at what all these tokenizations look like. And it should be more or less what you'd expect. So here we have the character token, so preamble, P-R-E-A-M-B, and head shows 6 by default, so that's all it is. The syllable token, tokenization, wow. Preamble, whereas so that should be recognition. You can see has split things into pieces that are slightly bigger than morphemes. I guess you could maybe argue that preamble has 2 morphemes in it, but I think for most English speakers this has calcified, and amble is no longer accessible as a plain morpheme. Right, like shoveled and disheveled. No one would say shoveled unless they were being like fun and playful. So I agree with the morpheme piece tokenization here that this is a single token. So the morphemes, preamble, 1 morpheme, whereas 2 morphemes, recognition, 1 morpheme. I might split this. I might say recognition. But I think it's also fine not to. And then of. So you can see as we have we go up in the sort of length of token, we get further and further into the text with 6 tokens, and this is just a morpheme boundary token. And for word levels, preamble, whereas recognition of the inherent, etc. So obvious things. The characters are shorter than the words. Also, the morpheme tokenization lowercase to everything, right? To make, so if where somewhere in here was also lowercase, that where uppercase and that where lowercase would be considered the same. Whereas with this syllabification, it was not, and I could have done some pre-processing to do that, but I don't generally recommend removing capitalization by default because you lose information that way. All right, so that's what they look like. And if we look at how many tokens are in our text, like, I mean, you can just think about it, right? The longer tokens there will be fewer of, and the shorter tokens there will be more of because the length of the text doesn't change. And sure enough, we have about 10,000 characters, 3,000-ish syllables, 2,000-ish morphemes, and 1,700-ish word tokens. Alexi says, there are examples where people would artificially come up with better ways to communicate with each other, like Esperanto, Interslavic language, maybe math notation. I'm not familiar with Interslavic language. I am very familiar with Esperanto. I have a friend who is a dedicated Esperantist, I would say. Hey, Nick, if you're watching. Math notation I wouldn't call a language. It is well, a formal representation and does not have a lot of the characteristics that languages have. And I'm going to save this discussion for later, but I don't think that necessarily intentionally designing language systems makes them better, right? Because there's always, when people are using language, there are pressures to, I want to communicate as quickly and clearly as possible. So there's going to be a strong pressure for me to communicate efficiently. And there's also going to be a strong pressure for me to communicate all of the information I need to communicate. And they're well-honed tools. As languages get used, as they change, they fulfill their purpose. I don't know. There's a pretty strong ethos in linguistics that human languages are all equally valid and good and worthwhile and important, which I would say is not reflected in how we treat the people who use those languages in the world as a large, but that's my stance on it. I believe there's a way to come up with something that could benefit our communication with machines through the current level of technology. I mean, we have programming languages, right? And they are pretty difficult to learn because pure formal logic is not something that tends to come very easily to humans. There's a reason why we had to spend time and effort to invent a system like that. So Andre says, Esperanto is only for the linguists, not ordinary people. Yeah, it's like you have to spend time learning a language, which in and of itself is a difficult thing, that you would be able to use mainly with this community of other people who speak it, which is, it's not nothing, right? But yeah. Alexi says, people are quite good in learning new languages. That is a skill that has variance between individuals. I am pretty good at learning pronunciations in new languages, but the closest I've ever come to failing a class has been Mandarin because I'm dyslexic and the writing system is hell. It's hell to learn. There's a reason there's a scholar class historically in languages that use that writing system. Anyway, we're getting off track. So looking at the length of the tokens, the number of tokens in the text, we can also expect an inverse relationship here with the number of unique tokens in the text, right? So the shorter the token, the more often it occurs, the fewer unique tokens there will be. And sure enough, that is the case. So you can see that we actually have more unique syllables than morphemes, which makes sense because many morphemes are multiple syllables. If you're wondering where we got 57 characters, it's because we didn't touch capitalization. So that's, 26 lowercase, 26 uppercase, and then a handful of punctuation marks. And then words, we actually had more syllables than words as well. So you didn't even get the benefit of having a smaller vocabulary size in this case. But as your language corpus size increases, I expect you would get to the point where you had more unique words than syllables. It's just not in this, 600 word document. And now I want to look at that relationship visually. I've made an error. Let's see. I didn't expect to live code. I did this yesterday. So this is for, what is it? Cannot converse class structure. These should all be there. Nope, there isn't. These should all be character vectors of length 4. Car tokens, syllable tokens, morpheme tokens, morpheme word tokens. Yeah, sorry, that's just me looking at that's just me looking at the spelling to see if my error is there. I want to show you the plot. Maybe it needs to be as data frame? Nope. Row names is not a character vector of length 4. Omitting it will be an error. Nope. Well, noted. What if I use the tidyverse instead of the base R? I swear it was working yesterday. All columns in tables must be vectors. Column types is a standard generic object. I have found my issue. It is that I did not use the correct variable name of the variable that I just created. Let's see, and I'm gonna go back to doing just a base R data frame. Standard generic types and tokenization types in. Right, and then also I need to use it here the same way. All right, little bug hunt there, but we should get a graph out. Fabulous. So I just wanted to show you here that there is a inverse relationship in a text between the number of unique tokens and the number of times they occur, right? So what I mean here is that this is characters down here. We have few unique tokens, but each token occurs a lot of times. And up here, right, so we have a typo is what we have. So up here we have words, right, which there are the most unique words, kind of. Imagine that there are. This would shake out with a larger corpus, and each word occurs the fewest times. So there's this relationship that's pretty stable between the, density of your type of token and then how many examples you're going to see in the text is sort of what I was suggesting there. And of course, I have made this error further down as well. I think I originally just used types and tokens as the number and then went back and fixed it because that's a built-in. Anyway, so here's, if you would prefer to see it in numbers, what it looks like. And this, pretty much holds across language data, right? The smaller the unit you're looking at, the more often you're going to see it. The more examples there are going to be, the longer the unit, the fewer examples, right? So just a pattern. And this is functions. I guess we can go over what it does if you're really interested, but let me know if you are. I won't do it by default. That also means that if we look at the frequency distribution, right? So if you're familiar with Zipf's law, the longer your tokenization unit length, the better an approximation of Zipf's law it is, right? So you get, lots of vowels, very few numeric, like 2s and 7s, etc. Those are down here in the long tail. So the more things you're going to have in the long tail. So you can see here the most common syllable is THE, the most common morpheme is THE, and the most common word is THE. And you are capturing those patterns pretty well with the longer token lengths, but not with the shorter token lengths, right? So it's the words are going to be, each word is going to be more informative. It's going to carry more information. I don't remember whether or not that's higher entropy or lower entropy because I'm always getting entropy backwards. But the fewer times you're going to see it, right? So it changes the distribution that you're trying to model. Yeah, Alexi says, maybe there's a way to develop something easier for people like you to read and write. Yeah, there actually has been a lot of work on particularly writing fonts for people with dyslexia. So Comic Sans was developed as an accessible font for people with dyslexia. Fun fact there. Also for me, as well as for all the people and machines in the world. Sorry for going off track. Nah, it's fine. All languages are equal except R. I'm not going to accept R slander. Look at this. Look at this. This was all of the data pre-processing and all of the plotting. Here's the plotting. It was one line. Look at that. It's just bar plot. It's a built-in. It's much easier to make charts in R. Anyway, so the longer your token, the more extreme the sort of elbow is going to be. And if we just sort of look at the most common words, and I know this function is called top n, but I'm actually going to do the top 25. If we look at the most common tokens, we can see that the most common character is the space, which is not super helpful in terms of knowing what this is about, right? So if we think about, you know, if we're doing, say, topic modeling methods using this tokenization, and my topic model comes back and says, you know what your document it's about spaces, you're probably not going to be particularly happy with that, right? Like this you know, sequence of tokens for the most common tokens is probably going to be pretty consistent across texts in a specific language, and not particularly informative. Similarly with the syllables, right? The and of to shun, like end of nation, in be, not super informative, probably going to be pretty similar across, you know, documents in this domain, right? And like things that come out of the UN, right? The token vectors, again, scroll down. Why won't you scroll down? Please scroll down. Right, well... I think I have to zoom out. I think I have run afoul of the JavaScript. If you look at the morphemes, you have the plural s ending and comma of to period, right, are the most common ones. But you have things like article, nation, free, which you also have up here. You can maybe imply that article shows up a lot because you have R and col that show up with the same frequency. Whereas if you're looking at the words, this is the most informative. So you have things like write, article, everyone, rights, equal, human, right? So at this point, you may or may not be able to figure out what the document's about as a human, just looking at the most common terms. At this point, I think, you know, you're much more likely to be able to get information about what the document's about. So the shorter the tokens, the less informative they are. Even though they show up a lot, the longer the tokens, the more informative, the more information rich they are, even though they don't show up as much. So all of these things like have a relationship with each other. And what you pick for your particular project is going to depend on what you care about, right? Do you need very informative tokens? So if I embedded character tokens, I probably wouldn't get a very informative embedding space. If I embedded the word tokens, I'd probably get a more informative embedding space. If I embedded sentence tokens, sentences add tokens, I'd get an even more informative embedding space, right? So like, Universal Sentence Encoder from Google, a project that does sentence level embeddings, and each of those embeddings is very informative. There's lots of information in it. Whereas, you know, a morpheme level embedding is just going to be less informative by its nature. And a syllable level embedding is not going to be particularly informative at all unless you're using a language where syllables tend to overlap with morphemes quite a bit. Right, so like this I here could be wherever we have a syllable with an I, or it could be like the first person singular pronoun. probably given this text, it's never the first person singular pronoun, but you might be tempted to be like, oh, that's definitely the first person singular pronoun, right? Like, I don't believe there's anything written in the first person in the Universal Declaration of Human Rights. So, a lot going on. Yeah, Alexi says longer tokens equals more information. Yeah, definitely in the tokens. And you can get that information back. You just wouldn't be able to get as much information with as little text, basically. But I also didn't talk about this in great detail. The longer your tokens, the more new tokens you will see when looking at novel text, right? So if you have sentence level tokenization, the likelihood that you're going to find the exact sentence, everyone has the right to education in any given text, is pretty low. Whereas the likelihood that you're going to find everyone is a little bit higher. The likelihood that you'll find the morpheme every, even higher. The likelihood that you'll have E, higher still. Almost 100, I would say, 100% probability of finding the letter E in an English text, unless it's that one novel that one guy wrote without the letter E. But that's a very atypical text. Yeah. Hi, Mostly Solutions. How you doing? I don't understand the existence of R. It's a specialized language for statistical computing. It comes from S. Specialized language for statistical computing, right? If you're doing statistics and analysis, it is a specialized tool for that. And also, I know if you've ever used, say, pandas, pandas is basically a port of some of the base functionality of R into Python. So a lot of the concepts there come directly from R as a language and those sort of like ways of manipulating data. R also shares a lot of sort of mind space and conceptual work with SQL. So if you're working directly with a database, like dbplyr is a really, it's just nice. It's a nice way to interact in a scripted way with databases without having to write raw SQL constantly. So yeah. Anyway, so that's why we don't use syllables in English, because they're not informative. You have to figure out how to do each one individually using a rule. And you don't get, the extremely dense, you don't get the extreme density that you do with characters, and you don't get the, meaningful embeddings that you... My dog's having a little itchy bit. Is that better? Okay. And you don't have the very informative tokens that you have with words. So, that's it. And this applies to English. If you're using a writing system that is not, phonetic at this level, things are going to be different. But that's sort of the general intuition. I think those general principles are going to apply, across different types of language when you tokenize them, right? So if you think about like sign languages, if you're tokenizing at the level of the whole sign, which is complex, there's a lot of grammatical complexity in sign languages. You're going to see, fewer repetitions of that sign than you might of a hand shape, right? So you might see lots of things with like this hand shape in different positions in different signs. And it may or may not be informative depending on the role of the hand shape in that particular sign. But you will definitely see more repetitions of it than a specific sign, or a specific sign with a specific, I know most of you probably don't know a signed language, so I'm trying to like figure out what would be a good way to describe this. The pointing, right, can be used sort of like a pronoun or a reference. So if I was like, the boy there, every time I refer to that place in space, I will be referring back to the boy that I've put there in space in American Sign Language. So the point, even if it's the exact same point, will mean different things, right, referentially, depending on where I'm interacting in space and what I've put in that space in the discourse. So like, the point to mean that specific person in that space is going to occur more rarely than a point to mean someone that I've put somewhere in space, if that makes sense. Anyway, so this applies to all languages. This probably applies to most languages. Gotta be careful of absolutes. People will get you with them. And I hope it was helpful. I hope to help you really think about, hey, Luke, I'm just wrapping up, sorry. I hope it really helped you think about, the way that the decisions that we make in pre-processing affects the type and the amount of information, and then the way that the information that we're looking at is organized and the qualities of that distribution. And yeah, just helped you think about it, right? So I think this is probably the most like important thing to think about, is that the longer the tokens, the longer your tail will be, which is, you know, challenging, but maybe what you need for your application. Alexi says, does syllable tokenization go into some sort of valley between character tokenization and the modern methods? I would say people are very much doing character tokenization currently, and I would say it's actually probably more popular than it was, you know, 20 years ago. And a big part of that is just compute, right? Character tokenization makes sense if you have a lot of parameters and a lot of training data and a lot of time to train those parameters given that training data. And that's, you know, I don't know, probably since the Audis, the mid-Audis, that's become the de rigueur in the field. Frank says, how do you know if languages are similar? Are there any tables you can look up different features? Great question. So what I would actually look up would be a taxonomic relationship between the languages. Keep in mind that two languages having a close taxonomic relationship does not mean that they are related. Their writing systems are going to be related. This is funny. Sorry, I just happened to run across something from where I went to college, which is not, here we go. I'm just going to take you to Wikipedia. List of language families can be a good way to look at things generally. So not to get too deep into history, but related languages share a common ancestor. So the Romance languages all share a common ancestor of Latin. So at one point, you know, the people who are now in Spain speaking Spanish, they have a link to, you know, through, you know, generational people they interacted with, back to people who spoke Latin. Or, you know, the Germanic languages all come from Proto-Germanic. So if languages came from the same forebearer language, they tend to be more related. They tend to have more characteristics in common. So I would look up like family tree of whatever language you're looking at. And just as I know some of y'all are in India, Indian language families are complex. It is one of the most linguistically diverse places on earth, not just in number of languages, but in number of language families. So especially if you're coming to Indian languages, in languages of the Indian subcontinent for the first time, be ye warned, it's a very rich area. Yeah. And I think I missed somebody, sorry. Dan says, are there tools for morphological analysis and context, sentence level or text level? An example that impressed me was unionize chemistry versus unionize in economics. So for that, you'd probably want a morphological parser. So parsing determines the relationship between pieces, whereas a tokenizer just cuts them, right? So there's no... like a morphological tokenizer would probably just pick one and go with it and wouldn't, you know, use the context of the sentence to do it. Whereas a morphological parser would probably consider the parse tree of the whole sentence when parsing, depending on the implementation. Did I make a video about the movie Arrival? I have not. I haven't actually seen it. I have a really hard time watching movies. So I have not, but I believe my friend Gretchen over at Lingthusiasm did a lot of content on that, so I checked that out. Have I studied Morse code? No. Nine Gaming, how different is Hindi, where each characters are pronounced as it is, unlike English, where e.g. Put and but have a different pronunciation of you? So I've only like very briefly studied Hindi. My impression is that there is more, the writing system tends to be a little bit more close to the pronunciation. English is particularly bad for a number of reasons. One being that we have a lot of loan words that we don't tend to phonologize as thoroughly as some other languages. Another being that we are not going to get into having an opinion on this, but arguably potentially a Creole. So we have a lot of influence from a lot of unrelated languages, which means we have a lot of words with different roots. So like something like 10% of all English words come from Greek, which is not a related language at all. So we had to like shove that into the writing system somehow. And also our writing system arose and was standardized in an area during the sort of popularization of printing presses. That's when the standardization happened. In a time of unrefined capitalism, or unrestrained, I guess. So basically every single printer had their own like set of standards and were bitterly committed to them. And before the printing press, our writing system was like much more laissez-faire, and you had a lot more information about sort of people's language variety in their writing than we currently have. Yeah, so I don't have a solid answer on, you know, how variable writing systems of Indian languages are. My impression is they're probably less variable than English. We've got it's hard to learn to read English for a phonetic language, put it that way. Luke says, etymology is one of my favorite things. Yeah, etymology is great. Alexi says, it would be cool to hear your opinion on how to make language models of small languages like Saka. I'm not familiar with this language. Let me look it up. Oh, it's Turkic. Okay, so it looks like in English it's sometimes written S-A-K-A, Saka language. So back in the day, language models used to be not based on enormous text, right? So they would be trained using things like Markov chains and a much smaller body of text. So I would just use the methods from 20 years ago and not the ones from today to build a language model for any language that's not English, basically. Alexi says, you remind me a bit of the protagonist from the movie, IDKY. I think it's played by Amy Adams. We do both kind of look a little baby face. Yeah, you're welcome, Nine Gaming. And Devin. All right, I'm going to wrap it up here. I did not expect this one to go on this long. But I don't know. I think it's helpful. I hope it's helpful. And I think it's really good to think about, you know, what makes language different, right? Because this pattern wouldn't fall out of like colors and pixels in images, right? If you took, you know, 10,000 photos or 100 photos, this sort of like underlying pattern wouldn't emerge in the same way, right? Like language has very specific informational properties that make it a good communication system. And because it's a good communication system, there's a lot of things that are true about it that are not true about other types of data. So language is special. Rachel Tatman. And yeah, you're very welcome. So thank you for joining, everybody. We have a special surprise this week, and that is, if you remember the random emoji generator I built on stream a while ago, I did it because I was designing a role-playing game system, and tomorrow we're going to be playing it. So I'm going to pull up the... Ooh, internet slow. I hope the connection is good. Alexi says squirrel, yep. Let me pull up the video real quick so you can see. So it's going to be with Jane Solomon, who's the lexicographer from Emojipedia, Jason Lee, who is the co-creator of Hanmoji, which is like a emoji with the Han Chinese language, Dr. Kirby Conrad, a good friend of mine who's a linguistics professor at Swarthmore, and then Phil Colleton, wow, from Kaggle, who is a data scientist, machine learning expert, and also builds games, so I hope he likes it. And it's going to be based on emoji, so I hope that y'all can tune in, and that's going to be at this time, 12 p.m. Pacific. Nope, 12 p.m. Eastern, so basically an hour ahead of this time tomorrow. Yeah, and I don't know what's going to happen. There's a lot of randomness involved in the system. So should be a good time. That'll be 12 tomorrow, 2 hours after my usual stream. And then on Thursday, it'll be my usual 10 a.m. Eastern week in review sort of stream. So I hope to see you at one of both of those or catch you on the replay. And thank you so much for tuning in. Stay safe, stay healthy, and I'll talk to you later. Bye.